strangely enough, this kind of thing started in the 17th century and ended only at the end of the 18th century, very late, even at the time where, it was quite understood that, the biblical numbers were not so precise. In the Bible, it is asserted more or less that the Earth exists till 5 or 6,000 years only. It's very short. In the Bible, it's way shorter than in India, where the tradition is propose a billion and billion of years. But in the Christian or Jewish tradition, or cosmogony, the Earth is not that old. So, but in the 18th century, we started to understand that the Earth probably exists since at least millions of years. It was very big for that time, and the first people that proposed million years for the Earth, a lot of people laughed to that. It was very considered as too much at the time, but still, but still at the 18th century, it was quite clear that this data could not be considered as reliable. But the last great mathematician that considered this data as interesting to study was Leonhard Euler. Maybe you know of Leonhard Euler? Yeah. Did you heard it? Yeah. Okay, so possibly the best mathematician on history, on one of the 5 best for sure, and he was he was Christian and very convinced that the Bible tells the truth, and he was asked by a specialist, a theologian, to answer a specific question. This is very kind of question, for example, I don't know which one it was, but I think it was, how many people were there before the flood? I don't know if you know about the flood. In the biblical tradition, God created the world in 7 days, put 2 people, so a man and a woman, Adam and Eve, and they generate people, and then someday God decides to destroy the world, and to destroy the world, this is done by a flood, and there is only 8 surviving people. It's Noah, his wife, and his 3 sons, and her on their 3 wives, and then the population can grow again, and God says that He will not destroy the world again, hopefully for us. But one of question was, how many people were there before the flood? That means how many people God killed. And this is the very kind of question Euler answered, and he answered it by setting up a mathematical model, which is what we know today as the study of the linear recurring sequences, which is one of the very important tools in mathematics, which have a lot of application. The Fibonacci sequence is the most simple linear recurring sequence, but there are others, and they are very helpful to do mathematics. And strangely enough, and that tells a lot for me, this idea and the first interesting theorems on linear recurring sequence were discovered by Leonhard Euler, but for a completely strange purpose, as it appears for us, because we can't find you can't find anywhere nowadays in Christianity anybody that will tell you, it's right that the Earth is 5 or 6 thousand years. There are some people that assert that, but in general, it's very only a few people think that. It's very few. But after that, the idea was that the exponential growth of population was something very beneficial and very interesting. And for example, there is a text from a Frenchman very known in France, but probably you don't know, you never heard of him, is Vauban. Vauban was a military engineer who put some military stuff around cities, walls, big walls, and very famous in France. If you come to France, there are several places in France with the walls built by Vauban. It was in the end of the 17th century. And Vauban wrote a text in which he says, well, take a pig, let him reproduce, and he do very complicated calculation, even more complicated. He take a linear recurring sequence, much more complicated as Fibonacci's one, and at the end of the calculation, he said, well, in only 10 years, for the first pig has produced 1 million pigs. So that's great. That's a political project because we can be helpful to everybody with that. Let's do that. He also proposed how to put population in the French Canada. At the time, part of the Canada was French, another part was English, and there was a strong rivalry between the two. And Vauban said, well, let's put people there and let win the war by population. So let's grow in population in the north of Canada. And also he made calculation and said, well, at that time we should be able to have that many French people in Canada, and we will be stronger than Englishmen. For the record, his calculation goes till the year 2000, and goes. I think he gives numbers each 25 years. So he gave a number for 1975. And there has been in Canada in 1974, if I remember well, there was a big census in Canada to count how many people were there, and it was the same number as Vauban gave. So in full Canada, but it was not. It was a coincidence because after, of course, since Vauban took an exponential growth in 2000, his number were way too huge than the real population of Canada. But still, at the end of this his calculation, it was almost right. So this is kind of funny. After that, and I'd say I'd be interested in know whether it's the same in India. After that, in Europe or in the Occident, the exponential growth started to become on the opposite, not associated to idea of wealth, but on the opposite, an idea of end of the world, and the population growth, for example, started to be considered as scary. And the first one who talked about that was an Englishman named Thomas Malthus. Did you hear of Malthus? Possibly not. Malthus is a demograph who's, don't know if we're really, let's say it's a demograph, who wrote a book, The Population Principle. And he begins his book by saying that the population each 20 years doubled in size. So 1, 2, 4, 8. He writes indeed 16, 32. He writes the sequence of the grains on the chessboard explicitly. And the possibility, the production capacity does not grow at the same rate. It grows at the arithmetic rate. You consider that it can grow because we can extend the fields or things like that, but in an arithmetic way. That means 1, 2, 3, 4, 5, 6, 7, and it's only linear. So at a time, necessarily, there are too many people and not enough food. So it's it's dramatic, and then the population diminish drastically, and then there is enough food for everybody, and it can start again and again and again. And he says he have a vision of the world in which the exponential growth breaks sometimes, then start again, then breaks, then start again, and say, well, we have to change that. And he is the first to really propose a political way, a political action on this. And his political action is very tough. It's very rude. He says that well, we shouldn't help the poor. The poor people should not be helped to survive because they reproduce faster, and they are the problem. It's very it's difficult to read Malthus nowadays. It's very, not a very good guy, indeed. And it's the beginning of a fear that we have, at least in Occident. I would be interested in your feeling from India. Is that the growth of population will eventually, all the earth will be covered by humans, and that will be the end of the world. The first man that had this idea was not Malthus. It was William Petty that I told you about. William Petty, an Englishman in the end of the 17th century. He made this very calculation. He proposed that, a doubling population, and at what time every single part of the earth would be covered by humans, and he said that, that will be the end of the world. And since he was very religious again and very Christian, he said that it will be the date of what is called latter day judgment. That means Jesus will be back. There will be a lot of events, and then the reign of God will be there. So for Petty, this idea that the earth would be covered by humans was very positive. He said, let's do that, because then Jesus will come back sooner. So he wrote this to a friend of him, and the friend of him said, you shouldn't write that. So we only have letters between them, but he did not publish this idea, but it's quite funny. So all of this just to say that a single old riddle in mathematics about grains on the chessboard has very different implications. And one thing interesting is also to see the way this story is written during time. When you read it before Malthus, it's funny. It's nothing bad. And then the difference is not at Malthus. It's the second part of the 20th century, where this story becomes, at least in Occident, a way to say, hey guys, stop the population expansion, stop the growth, the economic growth, because we can't multiply grains on the chessboard. We cannot support that. So now we're at a time of history, again in Occident, where exponential growth is a mathematical tool that is regarded as scary for itself. We are scary of a mathematical object, and even some mathematicians have this way of things. From a part, exponential is produce big numbers, very big numbers, and often the story of the grains on the chessboard is nowadays told by how many grains? How many grains? Tell a number. Oh no, 1 billion, 2 billion. No, it's way bigger, but you can't imagine how bigger it is. This is the way we tell the story here. First, you are unable to imagine. You have to be humble. You wouldn't imagine the number. Then I give you the number. Imagine, so kind of be flabbergasted by the enormous number. And then, you can't have it. You won't understand. It's too big for you. It's really this way, a quite common way to tell the story nowadays. Because for a part, it has become a mystical story, and it's intended to create fear. And in fact, this way of presenting the story is the exact opposite of mathematical way of studying it. In mathematics, you're not scared by numbers. Of course, sometimes you're surprised. Oh, this result, I wouldn't have expected it. Of course, we have to be humble. Most of the time, we do not anticipate result. We're wrong many times. That's okay. But then we work. We're not afraid of working. And we're not afraid, certainly not afraid of big numbers. And, and we can write it. And indeed, the best way, well, a part of the solution to this problem we have, again, at least in Occident, is to come back to some Indian way of seeing numbers. When Fibonacci, I told you that Fibonacci provides big numbers in the Liber-Abaci. He says, well, I put one chessboard, big number, okay, but even more bigger number, I put a second chessboard, okay, and I can compute. I'm not afraid of that. I'm confident. Good big numbers, no problem. I can compute that. There are another guys, but so this kind of confidence with big numbers was really I think a good attitude for a mathematician is appeared, in fact, several centuries before in again a religious text, and it comes from India. It's the Lalita Vistara. Maybe you know the text. It's a from Buddhism tradition. It were written between the 1st and the 3rd century. We don't know for sure, and it's the Lalita Vistara tell us about the life of Buddha. And there is an interesting part of the text in which, well, Buddha is not yet the Buddha, is only a bodhisattva. And we have to prove that he's a wise man, and he is confronted to a man which is which name is Arjuna. And Arjuna is said to be a great mathematician at the end of the science of numbers. This is the word. And Arjuna asked the Bodhisattva about, well, how can you understand the more subtle, well, the sentence is not very clear, how can you go deep into the most subtle atoms? A thing like that. And the Bodhisattva answers, well, in one, say, I'm not sure I have I should have taken this the quote, the exact quote with me, but he say, well, take one atom, take 7 of these atoms, and you will get a grain of dust, a small grain of dust. Take 7 grains of dust, and you'll get a bigger grain of dust that you can see by the sunlight. Take 7 of these new grains of dust, and you'll get a grain of dust that you can see in the moonlight. Take 7 of these new grains of dust, and you'll get a grain of dust that can be moved by the foot of a cow. Take 7 grains of this kind, and you'll get another grain of dust, even bigger, etc. And he goes further, and bigger and bigger and bigger. And at the end, and the last unit is he get a yojana. Yojana is a unit of measure, a big unit of measure. I think it's several kilometers. Sorry, I count in kilometers. So that's okay. and the last and the Bodhisattva then says, "Oh, so how many of you are able to tell me how many atoms are there in a yojana?" So you have to multiply all the numbers, and it provides a huge number. And Bodhisattva says, "What? Here is the number," and he provides it. And of course, everybody applauds, etc. What's interesting in this text is that the Bodhisattva at the time are not feared by numbers. No one around is feared by number. And the reason people applaud the Bodhisattva is not because he's kind of different of God. It's just because he's able to count. He's not scared by numbers, and I think it's important not to be scared by numbers, I hope that you're not, because you're interested in mathematics, and I find it good. And I think interesting that this kind of modern way of seeing big numbers and exponential growth, the first time ever we can see it written is in the life of the Buddha. That means not really a mathematical text, but a text of mythical or religious inspiration. So that's interesting too. Thank you all for attention, and if you have questions, I would be happy to answer them if I can. Thank you very much.